let's look at example 3. Here, we're going to notice a couple things before we even start the problem. This problem says find all the real zeros of f of x. So that's our hint that some of our answers will be rational, will be written as fractions, and some of our answers will be irrational, probably going to be roots. So in our answers, we're probably going to have fractions and roots here. Second thing we notice that in f of x, this is a degree 4, which means I should end up having 4 zeros or 4 answers, 4 x-intercepts. Next thing we do is we realize that we need to list our possibilities. You're not given one here, so you need to start by listing, using that rational zeros theorem to list all of our possibilities. Now, I would like you to practice that. So we have a constant of -8. We have a leading coefficient of a secret 1. I want you to practice doing the factors of the constant, everything that multiplies to 8, divided by the factors of your leading coefficient, everything that multiplies to 1, and come up with our list of possibilities. So pause the video, try to come up with that list on your own, and then come back to see how you did. Let's see how you did. List of possibilities, I have 8 possibilities, plus and minus 1, plus and minus 8, plus and minus 2, and plus and minus 4. If that's not what you got, pause the video until you can figure out where you went wrong and know how to fix it, and then you can come back and we can now try these possibilities out. So I've got my synthetic division all set up and started. Let's just go down the line. We'll start with our positive 1 and do our synthetic division and see if we get a remainder of 0. 1 times 1 is 1. Add those together and get a negative 1. That's a negative 1. 8. Negative 8. A positive 8. Positive 8. And hey! Sweet! This one worked out. We get a remainder of 0 right away. So x equals 1 is one of my roots. Fantastic. So let's write out our multiplication statement. If x equals 1 is my 0, the factor form is going to be x minus 1 equals 0. Hopefully you're starting to get used to going quickly on that. I have remainder, no x, x to the first, x squared, x cubed. So I have x cubed minus x squared minus 8x plus 8. So there we go. We are getting closer to our factored form. It looks like that we're going to need to do synthetic division one more time. Because remember, the key is to get down to a quadratic that we can factor or do quadratic formula on. We are not down to a quadratic yet, so we're going to need synthetic division again. So we're going to do our synthetic division again, but this time with this instead of what we started with. So this is our coefficients. 1, negative 1, negative 8, positive 8. Now, be really careful here. You do need to come up with a new list of possibilities. So we have the factors of our constant divided by the factors of our leading coefficient. And we will notice that this time it just so happens to work out that when we do the factors of the constant and the factors of the leading coefficient, we're going to get the same possibilities. Because the factors of 8, even though it's a positive 8 instead of a negative 8, are still going to be the same plus or minus numbers. And the factors of 1 will still be 1. So I'm going to relist it right here. Here is my list of possibilities. Now you may ask, can we take positive 1 off the list because it already worked? No, we actually cannot do that. Just because 1 worked once doesn't mean that it might not work again. If we try positive 1 again and it works again, that just means that this 0 is going to have a multiplicity of 2. It's going to have a squared on its factor because it worked twice. So just because it worked once doesn't mean you can take it off the list. You've got to keep trying it. However, if I had one that didn't work up here, so let's say I tried -2 and I found out that -2 doesn't work, that means -2 will never work. So for all my future lists, if I have -2 on my future lists, I can take -2 off of all future lists. So in summary, if it works once, it might work again. If it doesn't work, it will never work. So that's one way you can kind of narrow down your list of possibilities. So we said 1 may work again. Let's try it and see if it does work again. There we go. Okay, so 1 times 1 is 1. Add that is 0. 0 times 1 is 0. Add that we get -8. -8 times 1 is -8. And hey, x equals 1 does end up working again. Sweet. So now we can write our factored form out. Except this time, when I write my x minus 1 factor, I'm going to square it because x equals 1 worked twice. And let's look at what we have remaining. Remainder, no x's, so the first x squared. Looks like I have an x squared minus 8 left over. And now we are down to our quadratic. So now we can factor or use the quadratic formula if factoring doesn't work, which is wonderful. So notice this was a degree 4. I ended up needing to do synthetic division twice because that's what would get me down to my quadratic. So now that I'm down to my quadratic, I need to try factoring it first. Now this one does factor. Hopefully you'll recognize this as difference of squares, similar to if I factored this as x minus 4 and x plus 4. You've probably seen that before. I can do the same thing down here where this is x minus root 8, x plus root 8. You're essentially just taking the square root of this number, and that's what that one is. Square root of 16 is 4. So that is called your difference of squares. And now we look at this. I have my fully factored form. I have taken my big, ugly fourth pink one, and I have fully factored it. So to find the zeros, take each factor, set it equal to 0, and solve. And there's my zeros. Now, we can double check this because we said at the start of this problem, this is a degree 4, I should have 4 zeros. But right here, I only have 3 listed. Well, you actually do have 4 because remember, this x equals 1, we used it twice. So it has a multiplicity of 2. The other ones only have a multiplicity of 1. We use them once. So we actually do have 1, 2, 3, 4 zeros. So that trick, that fundamental theorem of algebra that we're going to learn about next time, does still work. The degree is how many answers you should have. Okay, that is all for example 3. The last example of the day is example 4, where we're going to try one that is to the 5th power.